Whoa, have you seen this? This is super important. It's called the quadratic, formula. And so looking at it, you're like, oh, what does the quadratic formula do? It tells me the answers for x. So those answers could be the solutions, the x-intercepts. And you can see that it's pretty gnarly. We've got a radical, we've got this complex calculation square, minus 4 times a times c. And so you're like, well, where'd all these letters come from? So they're gonna come from the standard quadratic equation, ax squared plus bx plus c equals 0. So it's very important that this is equal to 0 to start. And then the numbers in the formula come from a, b, and c in the equation. So here's a basic example. In this case, we see x squared, 3, and 7. And so you're like, oh, well, should I just factor this? So we've got b and ac here. That's going to be negative 7 and 3. And 7 is 7 times negative 1, or negative 7 times 1, which would be 6 or negative 6, respectively. So neither of those work. So again, this is an example of a prime trinomial, meaning not factorable. That doesn't mean that it's not solvable. But because this is odd and not even, we won't use completing the square. You could, but it would be fractions, so we're not gonna do all that process. This is where instead we're gonna use the quadratic formula. So a is equal to 1, b is equal to 3, c is equal to negative 7. These are things that we know from factoring. So to use the formula, we start with something called the discriminant, which tells us what kind of solutions we have. If this is positive, there are 2 real. If it's negative, there are 2 imaginary, meaning there would be a negative in the radical, so I would be in the solution. And if the number is not positive or negative, but is in fact 0, there's 1 real. So when I'm looking at this, I'm going to do this calculation, and the value will tell me how many solutions there will be and what kind, real or imaginary. So this time 3 squared is going to be 9 minus 4 times 1 times negative 7. So what you're noticing here, and I hope you're seeing this, is that there are 2 negatives. 2 negatives mean that the operation minus is going to change to addition. So this changes to 9 plus, I do the calculation, 4 times 7, 28. And 9 plus 28 is 37. So this is positive, so there will be 2 real solutions. That's what we know so far. Now 37 is a prime number, so that means that solving this one is going to be very simple with the quadratic formula. What do? We take this number and we're going to put it in here. So the answer is x is equal to the fraction. I'll do the 2a's, that's just 2 times 1. The opposite sign of b, so it's positive, so I'm going to write minus 3 plus or minus the square root of, and then I already did the work, 37. And that's it. So let me show you one that's a lot harder. This one is a lot harder because of the nature of the answer. So again, we would solve this using the quadratic formula. First, we'll determine the number of solutions with the discriminant. We do the calculation here. There's only 1 negative. And you can see I had to do my math over here. That's 90 and 54, which is 144. So 36 minus 144, that gives me negative 108, which means 2 imaginary. Which you can see that we wrote down just below. So 108, we know that that's going to go in the radical. And so I'm going to do that work over here. 108 is negative 1 times 9 times 12. But 12 has a 4 in it, 4 times 3. So I cross off the 12, and then I'm going to take all of these hanging numbers and I write them down below. 9, 4, 3, and 1, and then I'm translating them. The square root of negative 1 is I. The square root of 9 is 3. The square root of 4 is 2. And 3 doesn't simplify. So this is what we're getting from all of that, which means that this becomes 6I rad 3. So you can see again, just like last time, I'm starting with the discriminant. This time it was negative, so we knew I would be in our answer. And then we simplified the radical because it had perfect square numbers in it. Now I didn't immediately think of 36 times 3 because that's not something I memorized, but I did remember 9 times 12, and 9 is a perfect square. And then 12, I knew that had a 4 inside of it. So that's how we broke it down to 6I rad 3. So once you have this, remember it's going to be pretty simple. We're just going to take the opposite sign of b. So this time it was negative 6, so the opposite sign would be positive 6, plus or minus 6I rad 3 over 2 times 4, 8. Now that would be great, but unfortunately 6, 6, and 8, these plain numbers that are not in the radical need to be simplified. They can divide all by 2. So one way you can do that is to write it like this. That way it's very clearly divisible by 2. And then these ones, you divide those 2 by 2. All that to say our final answer is 3 plus or minus 3I rad 3 over 4. So you're noticing the rad 3 stays as the rad 3, but the 6 and the 8 both reduced. The 6 and the 8 both reduced. You can write it like this, or you could write it as 3 plus or minus 3I rad 3 over 1, 4. And that would be just as good, right? These two are equal. So if you prefer to write it like this, good. I prefer to write it like this with just 1. And let me make sure that that I is definitely shown. I. All right, that's it.